All right, welcome back. We are OOP3200. That's Object-Oriented Programming 2 at Durham College in the fall 2020 semester, and it's week 5. We're talking about collections and as well composition. Let's talk about this a little bit. So again, this week we're going to be talking about collections, chiefly two things. The standard vector class, I'm going to talk about that a little bit earlier in the semester, as well as array objects. And then we're going to, or objects of array, sorry. We're going to be doing in-class exercise number 4 together. And I've got a little starter up there for you, up on DC Connect. And Lab 4 is, I'll detail everything that has to do with Lab 4. We're sitting at week 5 right now, just to settle us in terms of what we're doing. So again, we're talking about dynamic object creation and deletion. That's something we'll be doing today. Pointers as class members, and inside of our destructors, how to get rid of them. And copy constructors, copy assignment operators, and then kind of like the rule of 3 is something that we're going to be talking about a little bit today. And but first, before we get into there, I'm going to start with the details for Lab 4. Okay, let's do that first. So here is Lab 4 details. So Lab 4, one thing to note is we've already provided you with not just a player card.h or playing card.h, but also a playing card.cpp. One also a thing also to talk about for previous Lab 3. Some people had issues with Lab 3 when it came to constructing their extended ticket class. And part of that was because of the date class that was also provided in that starter code. So the way to fix it, of course, is removing the static parts of the date class. I'll talk about that a little bit today when we get to it. But this, I'm also giving you a starter for this lab, and it includes both playing card.h and play card.cpp, and we'll talk about that in just a bit. So you're going to make your own collection class. So when I think about collection classes, I think about them as using other classes or other objects inside the class. I think but also as using composition, something called composition instead of inheritance. So inheritance is cool, and composition can save us in some ways. All right. So we're going to create something called a standard deck, which will contain or be composed of objects of the playing card class. So we'll talk about that. And then the idea or the intent of the class is to represent a standard deck of 52 cards that might be useful in a card game type application. Functionality of the standard deck class is mostly limited to the typical ways we use a deck of cards in a card game. And typically we might draw a card from the top of a deck or pick a random card from the deck. Based on that thinking, the standard deck class should not overload the subscript operator, so don't do that, nor feature any functionality that is not needed. So just stick to the kind of the functionality that we've asked you here to do. And it says extended ticket, of course, because that's a copy paste error. This should say requirements for the standard deck class is what it should say. Yes, of course. So what are the requirements? The default constructor, there should only be a default constructor for the standard deck class, and it should be set a member playing card pointer explicitly to 0, and then call a method called Initialize to allocate the array of cards. Let me show you what I've got for you first. So I'm going to bring up Visual Studio 2019, and this project is your starter code for Lab 4. So if you actually open that up for me, I'll do it the same as you. And you can find that starter code right inside of, let me just get rid of this, right inside of week 5's content area. If you go down, there is a area here called C++ Lab 4. C++ for Lab 4 details is here. So that's what I'm going over with you right now. There is a starter that's here. This starter is a zip archive. You have to unzip it and so on. And there's also the collections or the Lab 4 submission area. which I normally provide for you as well. So these are the 3 things that are up there right now. And I'm looking inside. Just basically all I'm doing is I've downloaded the zip archive equivalently, and I'm looking at it now in Visual Studio 2019. One thing to note is that both the PDF document and the zip archive is also included in your submission Dropbox. So if you go in there or grab these two, it's still going to be around. And you can always look at this later if you wanted to check and see what you did or what we were supposed to do. All right, so I'm with the starter code. I'm looking at your starter code for your Lab 4, and I want to talk about this a bit. So what I've done for you is a couple things. One, here is your playingcard.h class. So playingcard.h, Tom McDonald originally created this. I modified it, again, because I wanted to make it so it's more compatible with my thinking and so on. So slight modifications, not too much. But more or less what you have is an array of card ranks and an array of card suits. Okay, so for those people who don't know about cards at all, if you think about what a playing card is, you have a suit, and the suit is usually something like, well, it is actually, there's only 4 suits. It's usually clubs, diamond, ace, clubs, diamonds, I'll be okay. Spades and hearts. I'll be okay. I don't know why I'm flaking out this morning. So yeah, so those are the 4 suits, and then in the ranks you have numbers from 1 usually to 13, right? So there's 13 cards in each suit, and the ranks aren't just necessarily a number 1. Sometimes they'll be ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So those are the different ranks, if you will. So there's ranks and suits. So each card has, ranks, a rank or a suit. Okay, so that's one thing to note. So here we have a string that is the card rank and the card suit, right? So a string that can hold, all the data that you need. So when you inherit or when you use a playing card, then you have a couple of constructors. One of them is this one, a parameterized constructor that takes the rank, the suit, right, as an example. So you set it up, rank, suit, and some kind of value. I recommend where it says default value wanted, and this is something that Tom kind of put in place. Default value wanted. It's an integer, and it's basically saying that you need to put something in there. Okay. Usually the value is going to be associated with the rank. So example, an ace can have a value of a 1 or an 11 depending on how you see it. Sometimes also if you're playing different kind of card games, an ace might also be a 14, right? So it depends on how you're allocating the value for those cards. And also if the card is face up or not. So if the card is face up or face down, and think about it, just a deck of cards that we're talking about here. So that's one constructor. The other constructor is rank index, suit index, and then the value. So you get those 2 things, put in the value, and then if it's face up or not. So there's 2 ways to construct, using parameterized constructors, and one way to construct it using just a default constructor. So that's that. You have some getters and setters. I'm not really fond of getters and setters being kind of inline like this, but it is what it is. So, so a getter which returns the card rank based on the my rank index, right, and my suit index. Now, where are these values? And this is the same thing that might have caused you trouble in your Lab 3, because if you look at playingcard.cpp, right, you have some static data member functions here, all right, that are kind of created in the global kind of class space, if you will, right? So it's not something that's initialized somewhere else, it's initialized here. And if you notice in the date class of the previous Lab 3, these were actually physically in the .h. Because these were in the .h of the of the date class, it caused problems if you tried to split your extended work ticket across two files, the .h and the CPP, which we should be doing. So what I've done here, just to alleviate this, is I've split them up already for you. So I've taken the liberty of taking playing card.h and splitting it up in playing card.h and playing card.cpp, which is what we're looking at here. Okay. Let's get back to this. Sorry. So yeah, so this returns cards rank and card suit, card rank and card suit, with something that has with an index of my rank index and my suit index, and we'll talk about where that's coming from in a second. Okay, my rank index, right? It's an integer that represents the rank of 1 to 13, and my suit index, another integer that represents the suit 0 to 3. Okay, you can align those things. And then my value is an integer to represent the value of the card, whatever the card value is. So example, if it was the ace of spades, maybe it's going to be something, depending on what kind of game you're playing, 14 might be the value. You know, or if you're playing blackjack, it might be 1 or 11. It really depends on when it comes into the game. And then you'd have to kind of make rules for the game that way. Okay, default value wanted. This is a static const, and that means that it's going to start off as like 9999, negative 999, right? Which is not a value, but it's basically telling you that you have to replace these with some kind of value. Not that's why default value wanted is here. Okay, so that's kind of interesting. And these are the private instance variables: my rank index, my suit index, my value. Again, I might have, you know, kind of rename these to m underscore rank index, m underscore suit index, m underscore value, but it's up to you how you use these things. And so that's the card. That's the actual playing card class. Okay, playing card class. And then the playing card.cpp on this side basically just creates the constructor for you. The default constructor basically just does initialization. That's what it does there. So there's this constructor, which is parameterized, and then the other one that's parameterized. Okay, so that's kind of where it's at. Set rank, it's a setter that sets the rank of the card. And notice that there are set rank and set rank, and there's two overloads for how you set the rank. One is the index and the value. The other way is the rank string and the updated value that you want to do. So set rank, you can do it in two ways. Set suit and set suit. You can set suit in two ways. You can set suit with a number index, or you can set suit with some kind of suit string. It's totally up to you how you want to use this card class. Set value, there is only one, and there's also an overload for a standard string a cast operator. Right, so if you wanted to, kind of cast your, or cast a two-string, you can see that it's already here. It says the whatever. Let's say, for example, it was an ace, the ace of, and then the suit spades, the ace of spades, as an example, and standard two-string my value, so that it kind of produces a string at the end, and so you can use this inside of a cout or something like that. And then get default value. So that is your playing card class that you'll be using to construct your standard deck. I've included a very loose structure for your standard deck, and I make some recommendations. So here's your initialization section. Here's the rule of three. The rule of three is the destructor, the copy constructor, and the assignment operator. That's the rule of three. So that's what you'd have to put in. That's what we're asking for this lab. Accessors and mutators would go here, and then of course you'd probably put a private or protected area further down. These would all be inside of the public area. Okay, so that's kind of I've just made it so that you can start using it right away. And you don't have to worry about this stuff as an example, or including playing card.h. It's already done for you, and you can see that standard deck.cpp is blank. It just has the standard deck.h kind of include. So this is where you do all your work. Okay. In your main.cpp, we've included a pause function, and all this does is when you run this code, it just pauses the screen. And I've given you some hints. Okay, so things like create a deck. Okay, how does that work? Well, you have to make a new deck, right? Show the deck object as initialized. Okay, show that up, and then pause this pause function. If I was to run this right now, right? What it does is it shows, just press enter to continue. So if I press enter, it just stops right now because it doesn't do anything. But it pauses execution so you can see different parts of your code. And I recommend you use pause in several places. And since it's been given to you to use. Okay. Draw the next card and show it. Draw a random card and show it. Show the deck with remaining cards. Shuffle the deck and show the result. And reset the deck and show the result. You can probably put pause in several places here, and then do these operations. I recommend these operations for testing your deck of cards. Okay, that's what you should do. Okay. And let's go back to the requirements for a second. So that is what you get. So you're going to make an initialize method, which will be called at any time to set or reset the deck to 52 standard playing cards. So if I want to initialize the deck again, let's say I want to restart the game, I can initialize. All right, that's what it'll do. I'm going to make a destructor as part of the rule of 3. The rule of 3 includes the destructor to free or delete the array of cards, because you're going to have an array of cards in your standard deck. And you need to include a functional copy constructor and an overloaded assignment operator as well. So those 3 things is what I'm asking you to do in this number 3. Okay. Number 4, you're going to have a cards remaining method, which is going to return the size of the cards in the array, right? Draw next card method. Draw next card. It's going to go into the playing card object at position 0 of the array and remove that card from the array, and then you're going to reshuffle or move things around. Draw random card method and shuffle method. So those are the methods I want you to add. And notice it says here in your program requirements, your main function should demonstrate each of the features of the standard deck class. How you do this is up to you, but I've given you some hints on what to do. General requirements are the same for internal documentation, GitHub, and your video. Those are all the same things. And there is a suggestion that says, one suggestion is to create a new derived class from standard deck called card shoe. When the card shoe, you can have, let's say more than one deck of cards to use here, and this may be particularly useful. It says for your final project. Not sure what that means, but maybe something that you're going to be creating. So, so that's the structure here that I've given you, and I wanted to put this together for you as soon as possible again because I want to give you some time. This is due Sunday, October 11th, 2020 at midnight. Okay. Questions around Lab 4. So I know we're chugging along here, and I'm still going to mark Lab 1 and 2. My idea is I want to get Lab 1, 2, and maybe 3 done if I can by the weekend. I've already looked at your in-class exercise in there. I just give you, if you make a decent effort, I give you the marks. That's how I do it. So if you do the lab in-class exercise today, you'll get the marks. It's pretty straightforward. It's your practice or homework, for trying to understand what we're doing here on the C++ side. We'll do the same thing on the Java side in the second half of semester. Okay. All right. So this is your Lab 4. Hopefully that gives you enough information to get going on it. I highly recommend you start it as soon as possible. It's not that long, to be honest with you, compared to the other ones, especially since you've been given a structure to start with. And I'll see if I can do that every time to help you get going. Okay, so that's that. I'm also going to close this down. So I want to talk about, before I get into what we're going to be talking about today, I want to do a little bit of some lecturing a little bit just to get an understanding of how things work. So I'm going to talk about the standard template library vector. Now, if you notice, standard template library and templates, we hit class templates next week, generics and class templates, method templates, those kind of things. And then way down here, we're going to talk about the standard template library as we finish out our talk for C++ in the first half of semester. So this is where a couple weeks C++ is done. Notice it says vectors and linked lists. I've taken vectors and I've put it up here. I moved it up. Why? I will accept, I'm just going to let you know this, if you don't want to use an array structure for your standard deck and you would like to use a vector instead, I'm totally fine with it, but I wanted to talk about what vectors are. They're not vectors as in the vector class that I made and I included in today's in-class exercise. They're the standard template library vector class, and which is very array-like, as we'll see shortly. So just wanted to talk about that a little bit. Next week is a different kind of week than normal, as if you notice there is no C++ lab next week. It's only an in-class exercise that we have next week, which is great. It gives you kind of a week off, and then the following week, on week 7, you'll have everything: an in-class exercise, a lab, and a quiz, right? And the quiz will be based on these last several weeks, which makes up kind of your midterm mark. Okay, so everything should be marked by then as well. Okay, so let's get moving on this. So yeah, so here's the concept. The standard template library includes a data type called a vector, and it's similar to a one-dimensional array, and it has some advantages and disadvantages. We'll talk about what those things are. We also have the what is the standard template library. You're going to learn more about that in a couple weeks, but it's a collection of programmer-defined data types that have been successful, and these data types are not part of the C++ language, but what we do is we include them by using the an include. Okay, and we're going to talk, there's a bunch of different parts of the standard template library, and today we're going to talk about one part, which is the vector. Okay, STL basically, or the standard template library, is there the stuff that we get in there, the data types or the collections that we use are usually called containers. And they're containers because they store and organize data. There's two types. There's the sequence container and associative containers. A sequence type container is similar to an array, and associative type containers, which we're going to learn about again in a couple weeks, is like a map or a dictionary. Okay, so those are the two types of containers that you can have in the STL, the standard template library. Okay. When we talk about the vector data type, this is the one that is a sequence container, right? And it's going to have, there's a few properties that it has. One of them is it holds a sequence of values or elements similar to an array, okay? It stores them, and this is very special, in contiguous memory locations, similar to an array. But great thing about a vector is you can dynamically allocate space to it, whereas an array might be immutable. Once you've kind of allocated space to an array, it's there forever. A vector isn't like that. A vector allows us more flexibility in the way we do things. So we can use the array subscript operator to access individual elements, just like in an array. And there's other advantages that we talked about. For example, we can automatically increase the size to accommodate more space. So one great thing about a vector is we can dynamically allocate memory to it as we go forward. All right, so let's give an example of that. We have to include the vector import or include. When we do that, we create a vector by specifying what type it is. So this is where it's a little different. You probably haven't seen or used angle brackets. These angle brackets, what they are is, so left, it's kind of like a or less than sign and greater than sign. Anything in there is the type. And we'll learn about types like this, or this is kind of like template, if you will. That's why it's called the standard template library. We can make our own templates, and next week we'll start doing that. We'll create our own templates. But if you notice here, our vector of ints is what we're making. Like an array of ints, we're specifying a vector of ints. You can also make a vector of complex types, a vector of playing cards, as an example. And so you can do that as well. So a vector kind of acts like that. And you can also do things like this. You can pre-allocate a starting size. You can say, well, you know what? I want at least 10 numbers inside of my, or 10 integers inside of my numbers array, all right, or my numbers vector. And you can also use another specifier, so comma 2. In this example, we're going to initialize all of the 10 members, the 10 elements, with a value of 2. So this is kind of a very quick initialization syntax when we want to initialize vectors like this. That's cool. So that allows us to not only create a size, how big the container, how many elements in the container that are included, but also what their initial values are. Okay, so this is something that you can do with a vector. You can also initialize a vector with another vector. So for example, let's suppose I have a vector called set1. I can initialize set2 with the value of set1. So this is kind of cool, right? So I can kind of pass a whole vector into it. And this is a special container. So let's think about this. This is like me having something called like an operator overload, where I can make one vector point to another one. And it says after this statement executes, vector set2, as an example, is going to have the same number of elements that hold the same set of values as set1. So it's a copy operation. A copy constructor is being used here, right? If you're in C++ 11 or higher, and we are, you can also use initialize a vector with a list of values, so 10, 20, 30, 40, as an example. So that's similar to what we do with arrays. We can do the same thing with arrays, right? 10, 20, 30, 40. We use curly braces for these things. And here are some example vector definitions that I've included for you to look at. So a vector of int that's called scores with a size of 15. That's what this is, 15 ints. A vector of chars or cars or letters, which 25 of them, they're all initialized to A. Every one of them is initialized to A, right? And so on. Okay, so some great examples of this. Okay. So that is kind of vector initialization. There's some really cool things about vectors too. And how do we store and retrieve values from a vector? We use an operator, the subscript operator, square brackets, right? So here's an example. First of all, we have to include the vector, and then what we want to do is we want to declare two vectors here, a vector of ints called hours, where we have a number of employees, so 5 employees here, and a vector of double, pay rate, again, same number. We set the size of the container, even though they're empty. All containers, by the way, start off empty. They don't start with anything unless you specify that they have something inside of them, right? But you need to, once we do this, once we declare them, we instantiate the container as well. So that's something to know. And here's an example of where we retrieve the data. So we say, okay, I want to get data into this container. I just access it like I do any other array. That's the way it goes, right? So that's in, and then this is out, kind of thing, where I want to get values out of the array where I want to calculate the gross pay. So pay rate times the hours and so on. So pretty simple explanation, and so they look and feel very much like like arrays, but they're different, and they have additional advantages that arrays don't have, like we talked about. There's more. It's almost, think about it as a managed array more than anything else. In other languages, you might think of a vector as a list. Okay, so using the range-based loop, we can also use this. Instead of using a regular for loop, we can use a range-based for loop. And that's something that you may have not seen before. So a range-based for loop goes like this. For every value in, think about the colon as in, for every value in numbers, or for each value in numbers, then loop. Keep looping until I see each of the values in numbers. Okay, that's what a range-based for loop looks like. Okay, and the same thing goes here. If I want to get values in, I can do this. If I want to get values out, I can do the same thing. Again, I probably will use extra curly braces here because I don't like this single statement for loop. It's dangerous. So if I want to access the square brackets for a vector element that doesn't exist, it'll throw an error. one way we do it is we use the, when we add members, we add the pushback member operator, member function, to push back a value. So what it looks like is something like this. Numbers, this is the name of the vector, pushback, and then some kind of element that meets the same data type as the vector that we've declared. So vector of numbers probably is an int, right? So we push back 25, an integer value of 25 into the last position of the vector, at the back of the vector, okay? So one thing to note about vectors is you can push back, and when it comes to removing things, you'll pop back, and we'll talk about that as well. When I want to determine the size of the vector, I can use the size member function, which actually measures how big the vector is at any given time. We sometimes need that if I'm looping through if I'm using a standard for loop like this. So for every, for count is equal to 0, where count is less than the vector size, then loop, and keep outputting. This is another way of kind of outputting values, right? So the vector size member function. When we want to remove, like I said, we use pop back. So we add things to the back of the vector, we pop things off, or remove things from the back of the vector when I want to do this. So this is kind of one of the, I would say, kind of a way of accessing and removing elements. We can also clear an entire vector. So if I have a vector of objects, I can just clear it. I can just remove all elements. That's what that does. Be careful whenever you use the clear. It may not resize the vector appropriately. It doesn't resize it down to 0. For that, we would use something called shrink to fit. And shrink to fit would actually, something that we would reduce down to 0. Shrink to fit 0, so we remove all the elements. And we can change the size or resize the vector to 0. We can do that as well. And there's other things we can explore, which we'll do today. All right. How do we detect an empty vector? We can do that by number.empty. Number vector, let's say the vector name empty, returns a Boolean that says basically, is it true or false? Is it empty or not? And this is important because we want to see if there's anything in the vector. We don't want to try and access something that's in the vector, which can cause an error. It'll throw an error for us. First, we want to check to see if the vector is not empty. If the vector is not empty, then sure, go ahead, access the vector. If not, and if you try and do it, it'll throw an error. And here's some, I just put this page as a reference page for you guys. I know it's hard to see, and I don't expect you to read, but there's some additional things you can do. So I talked about them just now. For example, there is the resize function. And what the resize function does is it resizes a vector to a number of elements, right? Where n is greater than the vector's current size. If the optional value argument is used, this one, each of the new elements will be initialized with that value. All right, so that's another way of doing it. Size returns the size. Swap is interesting, and this might help you with your assignment. Look what it does. It says swaps the contents of the vector with the contents of vector 2. So you may want to do some stuff like that. Sometimes this could help you out. So I swap contents. I can have 2 vectors. When I do my shuffle, as an example, which is something that you're going to have to do, this might be something that's helpful for you. Again, you don't have to use these things. I'm just pointing them out as options for you guys to help you with your assignment. All right, so that's vectors. Any question around vectors, what they do for us? We're going to give examples of that in a sec. I'm going to do some examples of vectors. But also what you can do is if you don't want to use a vector or for your assignment, you could use an array of objects. And this is something that the assignment is made for. So let's talk about what this is. An array of objects is elements of arrays that are class objects, not primitive data types like integers and floats. And we know how to use these already, but let's suppose we're going to talk about them in more detail. So again, if I declare an array of object, let's say for example I have an object of a type circle, then I can declare an array of circle objects as circle and then square brackets, which is what you're going to see. So if I wanted to declare an array of cards, as an example, playing cards, I would have playing card and then card, and then how many how big do I want my playing cards to be, as an example. Okay. And there's some conventions for this. Usually when we use the same name like this, circle greater than, like with a capital, and circle with a lowercase c is typically used if we're going to make something of type and there's no special name or the name is, perfectly appropriate, because we don't want to make, I don't know, other kind of objects. I mean, this would be the circles array. You can call this circles, obviously, as well. We can also access class functions if everything that's inside of an array or a vector is actually an object. For example, an array or a vector of objects, which we're going to be talking about today, then we can access arrays or vector of objects with this syntax, where we access the index of the array, dot, and then the related member function of that class. For example, circle, the third circle inside of the third element inside the array, we want to use that find area, the find area for that particular circle. Okay, so that's how it works. So key points to remember about arrays of objects. One, elements of an array of objects, they can be objects as long as they are objects of the same class. So they can't be different objects of different classes. If you do not use an initialization list when an array of objects is created, the default constructor will be invoked. It is not necessary that all objects in the array use the same constructor. You can have different constructors in the array, which is good. And if you do use an initialization list when an array of objects is created, the correct constructor will be called for each object depending on the number and the type of arguments used, which is kind of cool. All right. So this is kind of where I want it to go. Let's continue with this. So it is also possible to create an array of objects and have another constructor called for each object. So for example, here is my object array, let's suppose, is number of circles. You can see that here I have 4 elements, so 0, 2, 2.5, and 10, right? And you can see that the radius, all I'm doing is I'm instantiating circles with using a constructor that only takes in one double. That's what it takes, right? As opposed to something else. However, if you really want to, what if I have the number of circles is 4, but I only define 3 of them, 0, 2, and 2.5. Well, the fourth one, right, would be the default value. Whatever the default value, you're going to call the default constructor, not a constructor that takes a double. All right, so that's the way the initialization works as well for an array of objects. And here's an idea of this, where I want to have different constructors. So I can use different constructors. I can specify which constructor I'm going to use for the circle. As an example, notice I use the capital C circle to construct each of the different types and then store a reference to each of these objects inside of the array, which is very similar to what you'll be doing with your playing card class, right? You'll be using, making a deck of playing cards. Okay. And again, here's an example of there's three different types of constructors, or 2 different types here. There's one that only takes a double. There's one that has 3 parameters, and there's another one that takes a double. So you can kind of swap between different kinds of constructors. And at the end, though, think about this. All objects of types in the circle array are going to be all circles. They're all the same thing. They're all the same data type. It's just that they can use different constructors, which is kind of cool. Let's also talk about an array of structures. So similar to what we did with arrays of standard items, right? So we have standard or primitive data types, or we can also make an array of structures instead of classes. So structures are very similar to classes. Can anyone tell me what the difference between, and for the people that are online, a struct and a class in C++? Can anyone tell me what the difference is? And I'm looking for some comments in the chat window. What's the difference? I mean, we can use them interchangeably for the most part, right? I mean, like I can use a struct or a class. Okay, a struct is more open to data, a data type. What else? What else? structs can't have functions and methods. They can, actually. Structs can have functions and methods. Classes have public and private. Structs are public only. No, structs can have private areas as well. But you guys are all circling around it. Basically, the only difference between a class and a struct in C++ is by default, classes are private and structs are public. That's the default, right? Their structs also have a slightly smaller footprint, and the way we work with them in memory is slightly different than classes. But that's the real difference with classes and structs. In other languages like C#, they're very different. In C#, structs are value types and classes are reference types. Here, they're both reference types. It's just a matter of their accessibility, public or private for the most part. Okay, so just want to let you know that. So it's like a class, but it's a struct. And notice that I have a collection. So this struct is a complex object. It has strings inside of it and a double. So we can think about this as a complex type, right? So an array of structures or array of classes, an array of class objects, same thing, kind of. And you can see that we access the actual structure itself, and I can access, because the a lot of times also a convention for structs is that we don't have getters and setters. Getters and setters, we don't usually include them. Can we? We absolutely can, but we don't, right? We usually use structs as, to carry data. All right, that's the convention. So structs carry data, classes are prototypes. Typically is what we do. All right, but we don't have to do it that way. Everything in your entire code could be structs if you really want it to be. It doesn't have to be classes. Now, for your assignment, you have to make it a class, but that's just in your assignment. Okay, so again, a book list, the sixth element in the array of type structs, book structs. Let's say as an example, we have a book list. This is your book info struct. So let's suppose I'm making an array of book info types, and I'm calling it book list. The book list array of book info has 20 elements. The sixth element, as an example, the title of the sixth element is what I'm getting out here, or I'm accessing somehow. Okay. And finally, we can loop through them. I can loop through the array in a very similar way that I do any other array. I do a for loop, and then I use the index to access members of the struct. So I have title, author, publisher, price. Again, you can see that this is almost identical to what we do with classes and objects. Okay, so very similar. Furthermore, we can go even further. I can say I want to get the title, but I want to get the first letter of the title, right? You can do that because the title is a string, and string is just an array of characters. Okay, so that is really, on a very high level, what I talked about here was the standard template library vector, an array of objects, which is something that you could use for your assignment, or an array of structures, also something that is possible for you to use. Let's do our example. So inside of, up on our in-class exercise, I have included a starter, which is here, in-class exercise. If you please download that starter for today's in-class exercise, that'd be awesome. I'm also going to do that. I'm also going to use the starter from the in-class exercise for today, right? So I'm going to go to Visual Studio 2019, and I'm going to go to that my starter, which is going to look like yours for the most part. Okay. And it's not there. Let's use the one that I have. Sorry, that's why I moved it around, because I wanted to use it. So, and that's perfectly fine. I've called mine lesson 5, which is what yours should be called as well. I'm just going to copy and paste it here. You can't see what I'm doing, but I'm just going to make a folder called here. I'm making a folder called ICE 4. Right? So in-class exercise 4 is what I'm going to be using today. So this is what I'm going to be starting with. Yours is called lesson 5, right? When you download it, it's going to say lesson 5. So let's start it off and see what happens. All right, so what have I included for you guys? That's the first thing. Let's kill this. So first of all, can you see what I've given you? Are you guys having any issues with this? All good on your end, Nicholas. Thank you. That's why I put this up, right? Okay, so immediately, remember what we want to do here with lesson 5 is I want to add this to source control. First thing, let's do that. So I'll say add it to Git. Here it is, right? And I want to push it onto GitHub, right? So this is something that we're going to do. It's going to go on to Durham Programmer, and it's going to be called OOP3200 F2020 ICE 4 in class exercise 4, publish. That's where it's going to go. Awesome. Okay, so now that it's pushed to Durham Programmer, you can follow along, or if you fall behind, you can always look there and compare my code to your code. All right, so let's go back into this. So what I've given you is a couple of things that I made, to help us understand a more complex Cartesian point object. And I've created a couple of things here that I've given you. One is I've made a vector 2D object. Let's take a look at this. Vector 2D, it's very similar to what you've seen before with Cartesian point, but I've pretty much defined all the arithmetic operators that I can think of, shortcut operators, comparison operators. I've got in here the subscript operator that I overloaded here. I've also done increment and decrement operators if I want to increase or decrease the vector itself. Now this vector, don't confuse this vector as the standard template library vector. Those are two very different things. This is my own vector, like as in math, right? Vector in C++, standard library, is not a vector in math, although it could be. So this is like my Cartesian point, but I've created something different than Cartesian point. It's much more detailed in some ways, okay? I've included things like some standard static functions, 0, 1, up, down, right, left. Think about this. If I want to go to the right, what am I going to do here? I'm just going to add 1 to the, or return a vector of type 1, 0. That's to the right, to the left, and so on. And I also have some additional utility functions that are static. That means I don't have to instantiate this vector. So I can do things like a lerp. I want to linear interpolate between vector A and vector B with some kind of t-value. I want to reflect the vector. I want to get the dot product. I want to get the angle. I want to get the distance between two vectors. I want to get the squared magnitude. I want to have the minimum between these two vectors. Which one? Take the two vectors and get the minimum value, return those out, and the maximum between them. I've created, the only thing that this vector has is a float, mx and my, right? That's what it does. So although it's a vector 2D, you cannot access the member variable, as an example, the x and y directly. You have to use getx and setx, or get y and set y. Just FYI. That's the way I've done it this way. Typically, our vector in other cases would be a struct, right? Because it makes the most most sense. Okay, so lots and lots of details here that I made for you. I also included something called a mathf.h class. Mathf is it's much more complex, and what I've done is included things like sine, cosine, tangent, and I've rewritten some of these functions specifically for our example. Lerping, moving towards a particular float, and so on. And this I've largely took, I have to be honest, and I'll say I unashamedly stole a lot of this structure from Unity's Vector 2D and MathF library. All right, so if you're someone who loves Unity 3D, you're a game developer, this is where I got all this stuff from. It's not like I came out of it out of my top of my head. So that's where it comes from. And then in my main, what I've done is, this is my testing rig. I've tested my Vector 2D, so I can access a point X and Y. Let's try and test it so that we know where we're starting today. Okay. So we're starting it off, and I've got, let's say, a 0.34, right? You can see if I just add a space there, it ignores the comma or the space, and then it'll, kind of make a vector of 3, 4. Okay, that's the first point. Let's do the second point of 5, 7, and you can see that it says here's the first point, here's the second point, and let's get the distance between the points and the magnitude of each of the magnitude of each of the individual vectors relative to the origin. Okay. So that is what I've created for you guys. Okay, great. And this is a nice testing rig for vectors, but this testing rig is not going to be sufficient for us for what we want to do. Not yet. We'll leave it here for now. What I want to do is I want to create a transform. Okay, so a transform is going to be a class as an example. So we're going to make a complex example. Okay, I want to make a more complex example. But just thinking about it again, maybe it's going to be too complex. Let's just do an object. So let's suppose I want to have a game object. And the game object is going to have a position. And my position is going to be a vector 2D. Let's suppose I'm playing a game that's a 2D game. All right, and I get an X and Y coordinate for that. So I'm going to use a vector 2D, and all game objects then would be of type would have or be composed of vector 2Ds. Okay, all game objects. All right, so is there like thunder? You really have thunder over there? I haven't heard anything, Nicholas. I can't hear anything on my end. I'm in Toronto, so I don't hear anything. So let's do that. Let's add let's create a game object like that. So again, for me to create a game object, I'm going to right click on my source files, and I'm going to add a new class. And in my class, I'm going to call this class game object. Okay, let's do it together. I'm just going to click OK now, and it's going to create two files for me, a gameobject.h and a gameobject.cpp. So the CPP points to the H. I want to do my guards. So whenever I make my class, again, good practice is, if not defined, I want to define my game object. So we've seen this before. And this is, again, a cross-platform guard so that I don't include my .h more than once. Little code here, defined game object. There we go. So that's my game object so far. I want to create a public area for it, and I also want to make a private area for it. Private and public. Cool. Excellent. Right, now in my public area, let's do that, the rule of 3. Okay, I want to make a destructor, I want to make a copy constructor, and I want to make I want to overload the equal operator. Okay, so those kind of things, all those things together. Let's see how this works. So first, let's make the constructor and destructor. So and also, I should probably have some member functions in here. So one of my member variables is going to be a vector. So I'm going to call it vector 2D, and my vector 2D is going to be position, the position of my game object, let's just say, right? Now, because I don't know what vector 2D is, I'm going to include it. So there's vector 2D. I've included my vector 2D as the position, the two-dimensional position, or the coordinate, if you will, of my game object. Okay. I'm going to rename this to m_position because it's private. Okay, that's the typical way I would do it. Okay. I'm also going to make, my constructor so that it can take two things. There's going to be two constructors and a default constructor. So let's talk about my default constructor. Here's my game object. So that's my default constructor. I'm also going to make a constructor, game object, that takes x and y coordinates. So I can say, we'll say that because my vector2 object, if you notice, my vector2 object takes in two floating point variables, mx and m_y, right? because this is the fact, right, and they're private, I can't access them, right? Then in my game object, one of them is going to take a float, which is x, right, and a float, which is y. I want to take those as an option. Okay, so the other constructor that I want to make here is I want to take in a vector. So I want to say I want to get a vector 2D. So vector 2D as an example, and we're going to call this vector 2D the position. So those are my my constructors. I'm also going to make a destructor. So here's my game object destructor, right? And my game object destructor is going to be, and why is this causing me to be an issue? Oh, it's because it's not found yet. All right, so that's kind of what my my structure looks like, right? So these are my constructors. And this is starting off with, like we said, the rule of 3. So one part of the rule of 3 is a destructor. Another one is a copy constructor. All right, so let's make a copy constructor. How does that look, guys? What does a copy constructor look like? I need your help. What does it do? How do I make a copy constructor? We have examples, by the way, already in this project of a copy constructor. All right, so their game object, there we go, const game object and other object. That's good. I like that one. So let's do that. So here's my copy constructor, game object, right? And then inside there we're going to take const game object and then ampersand. So that's the reference to the game object that we're returning. And we're going to say the other object, right? I like that. Other object. There's our copy constructor. And the other part of the rule of 3 is an assignment operator. Okay? So how do we do assignment operator? So how does that look? How do I start it off, guys? Come on. This is something that you're going to be tested on in your next quiz. So how do I do the assignment operator? I need your help here. I forgot. Right? And what does it return, by the way, the assignment operator? How does that work? The assignment operator is a little bit different than the plus operator and the minus operator and all those kind of things. Remember? Because it returns, I assign, similar to what I'm doing here. And I'm also going to ask that other deadly question, which is what's the difference between all these things, right? What's the difference? Okay, so let's do the assignment operator. So just, if you don't know what it is, go to their vector2d.h. You see that there are examples of the assignment operator. Look at the difference between these normal operators and the assignment operator. We have an ampersand sign in the beginning, which means it's going to return a type of, whatever it is on the right-hand side. Typically what I do is, when I do the right-hand side, there's the copy constructor. We did that one already, right? And I'm going to do that on the right-hand side as well. It's different than the other one, right? But so this is kind of what I want to do. Very similar in structure to this, except we don't use, as an example, just the name of the function. We also have another structure in here. So let's do the same thing with, when I go back to gameObject.h. So we're going to say gameObject is what we're going to get back, right? And then we're going to use operator equals, but we're going to put an ampersand sign, right, as an example up here, which means I'm going to return a reference to the object that I'm getting. And then we're going to do the same thing, const game object, right? And what I want to do is, we can say the other game object on the other side, and this is the assignment operator. Okay, so question, when does the assignment operator trigger, and when does the copy constructor trigger? They are actually completely, they do it in different times. When did you think that makes sense? When does it make sense? When does the one trigger over the other? When do I trigger the copy constructor? And when do I trigger the assignment operator? Does anyone know? Well, one of them, assignment is triggered with, well, they're both using an equal sign, right? They're both using an equal sign. But it's when. It's that important part. If my game object is unassigned, right, as an example, if it's never been assigned before, during declaration, if I assign it to something else, then I'm using the copy constructor, right? If my game object, or in this case my object, has already a value, and I'm reassigning it another value, right? If it's already been initialized, then I'm using the equals operator or the assignment operator. That's when those two things happen, and this will be probably a question on your next test. Just letting you know. All right. So that's the rule of three, and which is what is asked for of you in your lab 4 assignment that's out today and due Sunday. All right, so this is kind of stuff for the game object. I want to be able also to access and set my position and get position. So that's important too. Let's do that. So we'll say, so here is accessors, and here are mutators. All right, again, we can do this too. So let's make an accessor for my game object. My accessor is a getter. So it's going to return what? Well, it's going to return a vector 2D in this case, because I'm going to return the position. So I'm going to call this get position. All right, there's my my first accessor. I'm also going to set the position. So I'm going to say set position, but I'm going to have a couple of different overloads for this. I can set my position as an integer, for example, or float, float x and float y. That's an option. Or I also want to set the position by passing in a reference, to the vector itself, a new vector. So let's say, for example, a vector 2D, which I'm going to take in one or the other, and the vector 2D is going to be called new position. Why is this? It's very useful to be able to give a person options, right? Your user. Is it going to be a float x and y, or let's pass in the vector? If we have the vector available to us, let's make use of it, right? That is definitely something we can do, right? So get and set position. But there's two setters and one getter. Why? Because I want to be able to, return. We can also do something else. If we want to, we can always set or return other things too. If I want to get, my elements, my get position, instead of returning a vector 2D, I can do other things too. Okay, but for now, this is pretty good to start. All right, so for this, what I want to do now is I want to create since I'm making my game object, I want to do all the definitions. These are all the declarations. Let's do, when I click onto this, ReSharp or C++ says, hey, generate definitions by declarations. Let's make everything we need, and it generates all these things for me. So I'm good with that. I'll let that happen. All right, in my default constructor, what I want is for my vector2d to be initialized. So I'm going to say that m_position is just a new vector2d object that's empty. Okay, so that's the first thing. So that is my default constructor. It's going to create a vector, and notice if my vector2d does have an overload. If I go to my vector2d.h, if I put in 0 or nothing, it doesn't have a default constructor, but it basically has some default values. So 0, 0 gets sent to my vector2d. That's what it does by default if I don't put anything in there. Okay, let's get back out here. What else? So that's my GameObject.cpp part. Okay, this part. What about this? Well, if I give it values, I want to say that my mem_position, so I can do something like this. I want to say that m_position, I want to use the setter I could set my position here. So let's set my position. So we'll say set position, and we'll pass in X and Y. So this is something that is also possible, right? Because we already have a set position that takes X and Y. Might as well. Let's also make these const, because it makes sense, right? To make these const. There we go. And the same thing goes with the position. I can say set position, but I'm also going to set the position as, I'm going to pass in position, which is going to call the other position. There's two setters, X and Y. The other one is taking a whole vector, passing it in. Again, what I want to do here is use my const, as well as I want to make it pass by reference as opposed to pass by value. I don't want to copy the vector. In this case, I want to pass an object of that type, right? I'm going to create a reference, right? So that's my game object. My game object destructor right now, I'm just going to make, for now, my default destructor. We don't care about it at this point. We will later on. Because we have nothing to clean up, we're okay right now. We don't have a pointer or anything like that. And now we have our game object copy constructor. Remember, we want to do Memberwise Copy in this case, right? So how would I do that? Well, my only member that I have is my data member, which is my position. That's all I have right now, right? As a member, right? So I can say that my position. So I want to set position, right, to the other object's get position. Other object dot get position. Right, now this is something interesting. When I look at the other object itself, right, I can't use the get position. Why is that? Even though I've defined them, why not? Well, because of where they've been defined. But also, it's just, all I'm doing is I'm saying set position with the position of my other object. That's all I'm doing. Which is basically pushing down, and I could also do it, I can also do it in other ways, but this is kind of a way of saying, hey, take the other one and copy it over to this. Okay, so that's one. Next, copy constructor is, or the operator is the same, but there's some differences here. I still want to set position, right? Where I say the other object, but if I go dot, then again, I can look at M position. And then what I want to do is I want to return a reference to this, right? Because that's something that's going to help me basically, you know, I'm gonna do the same exact thing, except I need to return a reference to this. That's the difference between the copy constructor and the assignment operator. Okay. And get position. How do I get position? I'm going to return M underscore position, right? That's what it does. It returns a vector 2, right? As an example. And then my set position, this is cool. In my set position object, I'm going to set it with X and Y. So this is M underscore position dot set. And I can set set scale, you know, as an example. And there's also set, which I've created, which sets X and Y. Okay. So that kind of is something we can use from the vector 2 initialization. Or I can just say M underscore position, right? What I want to do is I want to make it equal to the new underscore position, because I'm getting a whole position. I can use the equals operator of the vector 2 object to do the same thing. But what we want to do here is we want to make a reference, right? Const. We want to do a reference to that particular vector. We don't want to copy it. Makes sense? So those are all the things. This also could be a const member variable because it makes sense. And one thing that we have, well, how about a toString or something like that? Does vector2d does it have a toString method or something like that that I've defined? So I have a casting operator where I can cast it, and I have a toString method here, right? Here's my toString. I want to make a toString method for my game object right now, right? So I'm going to go back to my game object.h, and in my GameObject.h, I'm going to have another accessor, or we'll call it a utility function. So utility functions. And one of them is going to be the toString method. I'm going to say toString, but instead of precision being 2, we don't care about that. We're just going to say we want the GameObject toString, right? And notice how I don't have to include string in here because I'm depending on vector2.h and vector2.h because it has, I included toString here or string here, then so too does GameObject.h have a string, access to the standard string. However, if you're really nervous about it, you can always include it as well. Okay, let's make a definition for this one. Go to definition or generate implementation. There we go. All right, so how does this work? So I want to output a new string. So I'm going to start with output string. So I'm going to say standard string. We'll call it output string. Output string, right? And what I want to do with this standard output string is I want to build it up. So I want to say that output string is plus equals to position. Because all we have is position right now, right? We don't have anything else. Okay, so this is this part. And you know what? It'd be really nice if my game object also had an ID, maybe some kind of ID, game object 1, game object 2. I don't have that yet, so why don't we, while I'm thinking about the game object, I'm constructing it, might as well add another private member variable called name or ID. So we'll make it so it's an integer, so it only has an integer handle, right? So we'll say integer, we'll call it m_id, okay? And let's make some getters and setters for this. So we'll get ID and set ID. So one thing also is in our constructors, if we're going to have an ID, well, it's not just game object X and Y. We also want to have a game object with an ID, right? So we'll say int ID, and we'll take in int ID, because it makes sense to have some kind of identifier to make each game object slightly different, 1 or 2, right? And it'll make our data type a little bit more complex, right? And when we set position is good, but I also want to get ID and set ID. So I'm going to say integer get ID, and we'll make it const, and we'll say that we'll set ID as well. So void set ID, which will be a new ID, right? So we have some stuff that we haven't done yet, and we just added those in. One thing, before we do let's modify our game objects because they're wrong, our game object constructors, because I just modified them. So I'll say that I'm going to have an integer ID as an example, and I'm also going to take an integer ID here, and I'm also going to initialize my ID here. MID is going to be equal to 0, let's say, by default. Notice I put it before the position because that's how it appears inside of my class. And so I want to set position, but I also want to set ID. So I'll say that set ID to whatever the ID is, right? I want to do that. And I definitely want to do the same thing here. So set ID. And we don't want to do this. We want to make it a const because that's a little bit more type safe than what we had before. Right, we can see that that's pretty good. Okay. Set ID, Tom. Yes, set ID. Okay, so ID, set ID, blah blah blah, and notice that these things here, they asked me a tidy fix for pro type member init, right? I'll come back to this in a second, right? What this does, it kind of initializes stuff for us. Let's continue. Our game object, again, this is cool, but in order for us to do our copy constructor, what we want to do is we want to say that set ID to equal to other object dot and its ID, right? m_ID. We want to get that and set that over, right? So we're doing a memberwise copy, and the same thing goes with the copy operator. right? So, or the equality operator or equals operator. So set ID and then m underscore. So it's other objects m underscore ID. There we go. So that's kind of an update. And as we go down to set position x and y, we can see that there might be a reason to do const here. That's what our resharper is telling us to do, and I agree with that. But down in here, we're going to say is, okay, so I want position. This is what prompted all this. I want position plus I want the ID to print to kind of show, right? So my ID, and we'll do one of these, right? And then we'll say plus get ID, and then plus. Now this is position, get position dot toString. I can do that chained methodology because guess what? My position is a vector 2D and toString belongs to that, so I can output a nice string there. Now we have to be careful how this is laid out, because if you look at, if I go back to my vector2d.cpp just for a second, you have to be careful when we're planning these things. Our vector2.cpp, and if I look for, by the way, you can jump to this thing. If I go up here to the top of Visual Studio and I choose vector2d, the class, and if I go here, I can get a list, a jump list of getting to anywhere I want in the vector very quickly, instead of just always scrolling down. So if I want toString, I just go to toString, or I can search it too as well. But if I want toString, I just click onto that and it'll just teleport me right there. All right. So notice what it does. It does, you know, a string stream, which is good. It'll convert it to string right here, and it'll output exactly how we think we're going to output, with no new line characters or anything else. This is good. This is what I wanted. So, okay, so I'm pretty good here. How about then, so this is going to be here, but what about this? It says, I'm adding int to a string, does not append the string. I want to toString it, so I want to do something like a standard toString. Standard toString, right? I want to, maybe an extra delimiter. I want to add this in so I can convert my ID to a string. All right, so that way it's going to show ID and position right now. Yay. And then I'm not going to do anything else. I'm just going to return that out. So I'm going to say return output string. I'm not going to make it so it, you know, prints out something or whatever. Just this, an ID and position. Pretty standard stuff, right? Nothing too crazy. And let's see, what we need now is anything that's not been not been defined. So we're going to go up to this top, and we're going to go to here, and it's going to say generate definitions by declarations. It's going to give me the two that I don't have, get ID and set ID. Let's do those. So here's get ID. We're going to return m underscore ID. And as you guessed it, set ID is m underscore ID is equal to ID. And we can make this const. Okay. And notice it's just complaining about my naming convention. I don't care. I like my convention. So those are my, this is my game object. I made my game object, right? So this is what it does. I'm pretty happy with it, you know, I think. But I haven't tested it. So let's test it, and then let's put it up on GitHub, so you have this too, instead of, you know, you watching, and we can do it together, right? So I want to make a new game object. That's what I want to do, and I want to output. I want to set it up, and I want to output it out. Let's use the main.cpp as a way of doing that, right? And I can get my x and y coordinates. Instead of doing 0.1 and 0.2, I can have two game objects, game object 1 and game object 2, that have position vectors. So we can use the same structure, is what I'm saying. So here's game object 1, and this will be game object 2. Okay, let's do it. So we'll just rewrite some of this stuff. So instead of 0.1, we'll call this game object 1. So we'll say, we're going to have some errors, but no, not a problem. We'll take care of them. So we'll say game object. We'll call this game object 1, right? And here it is, right? We'll add game object up here. curious, do I need vector 2D now? Well, no. If I take vector 2D away, right, it's okay because I know about vectors because game objects include them. So I don't need to have them in, right? Now, what I want to do is I want to get my game object. When I construct, this is constructing my default object. And what I want to do instead is I want to take in, do I have an input for this? Well, I do actually, because point 1 was a vector, and vector 2Ds did have an overloaded input operator. Let's do that. So we'll say game object 1, right, dot, and I want to set position or get position. Now if I get position, this returns an object of type position, but what I really want to do is I want to set position to the value that I get in. So there's a couple ways we can do this. Let me just back up here for a second, just a second. What if we made some temporary values? We made point 1 and point 2. We'll keep that back in there, vector, because it's going to behoove us to help me do this, right? So this is point 1. What if I did this, but after I did point 1, right, I made game object use it. So that would be the way to do it. I would say, hey, game object, we're going to say that, my game object 1 dot set position. I want to set position to the point 1 that I entered. So I'm going to enter it like this. So I've entered it in, and then I'm going to set the position. There we go. Okay, and then I want to do the same thing for game object 2. So I'm going to make game object 2. So game object. Okay, there's game object 2. Point 2 is there. I get my point 2 in there, make a new point, and I'm going to say game object 2 dot set position. I want to set my position to point 2. We're missing some stuff, right? We're missing some stuff. I also want to get my ID, set my ID for my game object. I'm not doing it all at once. I'm doing piece parts to it. I could set my game object right away with all my details, but instead I'm doing it like I'm getting in some stuff entered and I'm returning it. And by the way, I'm not going to do point 1 and point 2. I want to return game object 1 dot position dot get magnitude, game object 1 dot position, so get position dot get magnitude. I can link those together, and game object 2 dot get position dot get magnitude. All right, so I can do that, right? So I get the magnitude of those things. And the same thing goes to the distance. I can do vector 2 distance between 2 points, game object 1 dot position, get position, and game object 2 this time, right? Game object 2 dot get position. So you can see that I can still use them as normal vectors in my regular thing. And my signed angle, I can also get the angle between. I'm just going to copy paste now because I've got this situation happening already, right? So this is this, and I want to take this part and put that in there. There's my game object, the difference between the two game objects, where they are. And instead of saying first point, second point, first game object, second game object, right? So first and second game object, right? That's what we're actually using it right here in the game objects. And here we're setting the first point, point 2 you entered for the second game object, just so that we know what it is, and the first game object. We could have done this in one, but I'm just pointing out how this looks right now with what we have. So first object, second object. We need an ID, all right? So we're going to enter the ID as well. So this part right here, I'm going to just duplicate it, right? And what I'm going to do is when I make my game object, the first one, it's going to say enter first game object ID. First game object ID, right? And we're going to say that game object. Now, considering how this works, can I overload? Can I do this? Can I kind of do the overload thing? I can't. I don't have this, and we can cut this down later on by making an overloaded, a couple of overloaded things. But for now, what I'm going to do is make a temporary variable called int, right, ID1, right, just like we did. This will work, right, and I'll say ID1 because it'll kind of, you know, I can get an ID, store it in ID1, and then take my game object. So far I'm setting position, right? But instead of constructing my position by setting position, what I could do now, because I have this, is I could set my game object, right, altogether. And I don't have a function for that because I've already constructed my game object up here. So what I could do is just move this declaration, because I'm not really using it until later on, I could just move it down to here, right? So I could say game object, and then I'm going to say that my ID is 1, ID1, and point 1. And this is going to basically, it says it may be const. Yeah, I'm not going to do that. But that is using the constructor that takes a point and an ID. Okay? Let's do the same thing. We can actually reuse ID and point vector point 1, but I'm not going to do that here. I'm just going to do two separate ones for this example. Right, so again, I'm just going to copy this structure for the first game object, and I'm going to put it right before this one, right? So this will be int 2, there we go, for this second. And we see that we're duplicating, right? We're duplicating these game objects. This is the entry text that we have, game object ID. We'll put this over here, and this will be game object 2 with an ID of 2 and a point of 2. All right, so that's kind of how that works. We'll get rid of this. And you can see that these areas here are identical, pretty much. This just says game object, first game object, and second game object, but it could actually say for ID of whatever, right? Okay, cool. And here we have our difference between the two things, and I want at the bottom to show my first and second game object. So I can say standard cout. We'll say that first game object details, right? And then standard end line, right? And I'll say standard cout with my first game object 1 dot toString, which will print that out. Okay. And I want to do the second one, the second details as well, right? So we'll say second object details, second game object details, and it'll game object 2.toString. So this is kind of full cycle. And that is our testing rig to make sure we can use a game object that has a vector 2. All right? Let's run this thing and see if it breaks or not, right? And what does it do? All right, so my first ID, I'm going to make it so that this is ID 1. My point is going to be 3, 4, right? It says you entered 3, 4 for the first game object. Cool. I didn't actually return the ID number, but that's okay. For my second game object, what's my point? Enter the second game object ID. So 2. What's my point? It's going to be let's say 10, 20. Let's use a comma here and see what happens. 10, 20. Enter. And it says, okay, you entered 10, 20 for the second game object. The magnitude of the first one is 5. The magnitude of the second one is 22.36. My distance between the first point and the second point, this just said first object and the second object, is 17.464. The angle in degrees from the first vector to the second vector, or from the first game object to the second game object, is 10 degrees, approximately. My first game object details ID is 1, position is 3.4. So this didn't quite print out the way I wanted it. I would have liked this to be on separate lines, some separation between the top and the bottom. All right, so let's fix this output because it's not exactly what I was looking for. So going back to my GameObject.cpp, we can go down to this, and what I forgot to do is add in some kind of \n, a new line character here, and I'm going to add a new line character at the end of this for now. So this is okay. And going back to my main.cpp. So again, just another example of what we're doing. I want to give myself some space here. So let's add another one of these and fix up some of those areas that are not laid out properly. So instead of first vector, second vector, we'll say first game object and second game object. Shouldn't say vectors because we're not just doing vectors anymore. The two game objects are separate, right? And same thing with first game object and second game object. Right? So I guess I've just renamed everything. Wonderful. All right, let's run this thing and see if it works. Cool. So I want to say enter 1, 3, 4, and 2, 5, 8. And then you can see that the distance is only 4.472 between the first and second. They're pretty close. And then the angle between the two is about 4 degrees, 4.865 degrees. Here's my first game object, and here's my second game object. All right, so that's pretty good. And I got these backslash n's in here. Woohoo! It should be the other way around. Wow, I'm really sleeping this morning. So let's go back to this and put these as backslash n's, not /n's. And this is all. I'm not putting this on GitHub until I have the correct values, right? One more time. So again, 1, 3, 4, 2, 5, 7, and then we go. We have everything now. It looks a little better than it did before. A little better. Cool. This is a great place to put it up on GitHub. Let's do it. So I'm going to go to Team Explorer before we finish off for today. I'm going to go to Home. I'm going to go to Changes. I'm going to say Added Game Object Class. Right, commit all, home, sync, and push. So this pushed everything up to our code. Wouldn't it be nice if, and this is where we're going to get to the last part of our little exercise here, wouldn't it be nice if instead of I did this whole thing in some kind of loop, and I had a vector of game objects that I wanted to create. So let's say I want to create a bunch of game objects. I should be able to say, like, how many game objects do I want to create? And then I want to create those game objects. Let's try that. So I'm going to say up here, instead, let's rework this. So I want to say, how many game objects do you want to create? How many game objects do you need? Right? So we're going to say how many. This is going to be num of game objects. So game object number or number of game objects, num of game objects. We'll call it num of go for number of game objects. Yeah, really exciting. So number of go is going to be basically how many game objects do I need. I'm going to now do one of these where I kind of space it out. And what I want is some kind of vector of game objects. So I want to create a vector of game objects called game objects. So I need a standard vector. So standard vector is how I do it. In brackets, in angle brackets, and it tells me to add in a standard vector. All we have to do for this, by the way, is we're going to put in up in the top here an include, which is of type vector, like this. So standard vector of game object. And we're going to make them game object pointers, just to make it all that much happier. Game object pointers, which we're going to call game objects. Game objects. Okay, now take a look at that structure here. So vector of game object pointers. That's interesting. That's kind of similar to what you're going to have to do. And how many do I need? I'm going to say this is how many. Well, what I want is when I construct something, let's build our vector. I'm going to make a new function really quickly. And I know I'm going to time out here, guys, but bear with me. I make a new function called build game objects, right? So it's going to be a static function called build game objects. Build game objects, right? And it should be static void, not void static. build game objects. And this build game objects function, what is it going to do? It's going to do this, right, in some sense, right? And what it's going to do is when it builds game objects, right, I'm going to call it down here. So build game objects. And build game object is going to do a couple things, right? I want to pass in a reference to a standard vector of type game objects. So the way you do it is you say, okay, I want a standard vector of type game object, right? And my standard vector is going to be called the, we'll call this game objects, just to make it different. So I got a reference to it. That's what this does. Okay. So a reference to this vector here. That's what I want to do, right? Cool. So then, if I want to access game object, look, it says, "Hey, by the way, Tom, maybe you want to, do something here, a tidy fix, because you want to probably make it so that it's a, it's a reference to the game object, right? So I can just pass in game objects here, and it basically says that if I want to do this, I need to, I want to pass in a my type. Now notice it says this is my type. Let me go back out here. When I do game objects, it's a game object pointer, not a game object type. So this is okay now. And the other thing is maybe I want to name this as P game objects, a pointer to game objects. A vector of pointer to game objects is what this is, okay, to make it more complex. Pass in game objects, so this is my game object array, and what I want to do is, depending on how many I want, so again it would be here, how many is the other thing I want to, so build, I want to get my array, and how many do I need? So I'm going to say, the number, right, so int number, my int num, as an example, that's the number of game objects. I'm going to say that the default, if I don't pass anything, is 1. Okay, so I'm minimally going to create at least one game object, right? So if I do 1 here, it's okay, same thing, right? But what I really want is I want to pass in number of game objects. That's what I want to do. So when I say how many I want, and then it's going to build them up. That's what this build game object is going to do. So all of this stuff here, I want to take this, I want to copy it, I'm going to put this in here, right? Where I'm going to say, cool, game object is going to be this, right? I'm going to make a temporary ID. We're just going to rename this ID instead of ID1. So refactor, rename, so ID. And we're going to redo the point, refactor, rename. So let's call this point, right? There we go. So this makes a game object of point ID and point, and this is not game object ID for first game object. We're just going to say for the game object, for the point, for the game objects, for the game object position, which is what this is, in X and Y coordinates. And then you entered this point for the game object's position. Game objects position, right? And we also want to do this for the game object's ID, right? So what we entered. So standard cout, and you entered ID for the game object's ID. Wow. Okay. So this is something that we want. We want to build this, but we want to do it num times, right? We want to do this num times. I want to add this into my game objects. I'm going to say game objects, this one, dot pushback. I want this thing, right? And I want to do a pushback, right? So notice I say I can't do, it's an array of game objects, but how do I access it? So notice that I can do these things, back, begin, blah, 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 blah. I want to do pushback, right? That's what I want to do, pushback. So if I do pushback like this, and I type in, as an example, the game object that I want, I'll pass in a game object, object. Right, here's my game object. Well, I can't allocate memory this way if I make it a pointer, right? I have to allocate memory that looks like this. Game object itself is equal to a new game object. That's what I need to do. And the reason why I'm not getting my game object here, right? And if I look at what it says no instance of overloaded function standard vector pushback with game object star matches the argument list, right? Types are game object and the standard vector type allocation. So what would be the problem, do you think, here? Well, how about if I did this? Is that good enough, right? Well, no, that's not good enough, right? This doesn't make any sense. I'm pushing back a vector to my game objects array. This is what's happened. This is my game object. If I was to do that over here, if I said game objects dot pushback, I can do it here, right? Here's my, I can push back over here. And I'm getting a reference when I pass it over to game objects, right? Here it is. But I made it const. And I can't make it const, guys. So that's the one thing I cannot do, right? Making it const does not allow me to do that. I can't do it this way. The other thing is that pushback is okay. It says game object. I need to make a game object pointer, right? Game object pointer, right, is equal to a new game object. So this is the game object pointer would be game object pointer. Oops, pointer. So that makes a new game object pointer, right? New game object, storing it in the game object right here in my game objects thing. And this is for each one. So now let's make a for loop. So I'll say for, and I'll do a for I, where my count is less than number, right? So I'm going to kind of count this many. And I'm going to do this loop over and over again. So push this into this. So I'm going to add multiple game objects now to the array, to the vector, right? So it says game object, use auto when initializing. Sure, I don't mind doing that. I think that's pretty good if I don't know. Auto basically tries to find the type by itself. That's what this does. So then it pushes the game object. That's what this does. It also says probably going to use const or the tidy fix. This is a kind of a way of doing that. So it makes it nice. This should be const. Let's fix this up. It's a number. And this is how many, this is building my or constructing my game objects array. This should be auto, right? And there we go. This is the way I can get multiple game objects inside my game objects vector. And it's an array or vector of pointers to game objects. Cool. I need this part, but I don't need any of this anymore. So marching down here. All right, so yeah. So instead of using my position 1 and 2, let's suppose I have a minimum of 2. So if I don't specify, instead of making it 1, I want to say at least 2, right? And but I'm going to specify a number of game objects. I want to get the position magnitude from game object 1 and game object 2. I want to use the same structure right now. How do I do it? Well, when I access the game object that's inside of a vector, I need to do something that looks like this. I need to say, hey, game objects, right? I want to get the first game object, right? So the first one, or the 0th one. And instead of get position, I want to do the arrow. So I'm going to say, hey, get position. Arrow means it's a pointer to the game object that's sitting inside of here. So that's the syntax. And this will be game object 1. Now these are fixed. We would probably make it differently later, especially if I wanted to do between 2D, if I want to specify which ones to do. We haven't got that there, and we're going to run out of time. But we're going to continue to use this example in coming scenarios here. So this is game object 1, and we're just going to say we need to use the arrow instead of the dot because it's a pointer. Okay, arrow instead of the dot. I'm going to put these over 2 lines. We're going to do one of these so you can see what they are. Okay, and the same thing goes with this one. I'm just going to put this over 2 lines for you. So this is game object 0. So the distance between game object 0 and game object 1. I'm going to get the position from game object 0 or game object 1. This is very similar to what we did with structs or arrays of structs. That example from the PowerPoint. And same thing with the assigned angle. That's not going to be any different, right? Cool. And the same thing goes with, I want to print out the first game object and the second game object, whatever that is. So toString for the first one and toString for the second one. You see, I just use the arrow instead of the dot every time. All right, so this is the exact same. We'd probably want to change this up to specify which game objects do you want to look at. I want to look at, here I'm looking at, always looking at 0 and 1. Maybe in the future I want to make it flexible so I can look at whatever I want. Make a function to do all this as opposed to have it here in main like I've done here. All right, let's see if this craziness works or if it's totally broken. So save and run. Okay, so how many game objects do I need? Let's just sit with 2 for now. My ID for enter the game object ID. So it's going to be ID 1, 3, 4, right? So you entered 1 for the game object ID and 3, 4 for the game object's position. Okay, a game ID is 2, and then 3. Sorry, we'll say 5 and 10, and it does the exact same stuff, right? 511. 6.325 in the distance, and there's the angle between game object 1 and the second game object, 10 degrees, and this is object 1, object 2. So it did all the exact same stuff, but we did it dynamically. Instead of us knowing how many game objects we have, we can have as many as we want. Last thing, so I want to make this more generic. I want to specify compare which 2 game objects as an example, and that'll be the compare objects or compare game objects. We'll make another static function. So static void. We'll call it compare game objects. Compare game objects. And we'll say game object 1. So we'll pass in 2 pointers. Game object pointers. So object 1 and game object pointer object 2, okay? And this is our structure. I'm going to basically take all of this, put it in there, right? And instead of saying game object 0, 1, I'm just going to pass in object 1 for game object 1. Actually, let's just copy paste or find replace. So I'm going to specify an area, Control F. I'm going to look for game objects 1 and replace with what is replace? Edit, replace is H, I think it is, right? Find replace, find and replace. Quick replace in files. Yes, okay. So I want to find game objects 1 and I want to replace it with object 1. Okay, so let's do all the replacements. And let's do that again, undo. Let's specify the entire thing. So my selection only. And let's do the replacements, 4 replacements. Okay, let's do the same thing. Game object 0. Actually, that was wrong. Let's undo that change. This should be object 2 actually. Replace all. And this will be object 1. 0 is 1. Object 1. So again, we're going to specify this whole selection. and then replace all. There we go, forecast. So that we've done all those things. So it's the same thing, right? Except we have object 1 and object 2 instead of a fixed some number of objects. I know I'm timing out, guys. Bear with me while I finish this off, and then I'll put it up on GitHub for you guys. And this is your example. All right, so I need some input. Object 1 and object 2. So which objects do you want? There's no checks here. We have lots of stuff we could do, you know, as an example. So which two objects do you want? What's the first object? What is the first object ID? Right? And then we're not going to need this. Actually, we'll say int ID1, right? And we'll say ID1 here. And we'll do the same thing with the second object ID. So we'll get in the first object ID and the second object ID really quickly here. We can do this also better than this. Second object ID, right? So I get first and second object ID. Then I can do the compare objects. Compare objects, game objects, where I pass in the game object 1 and game object 2. But I can do that by accessing the vector. So game objects, right? I'm going to pass in a 0 or the ID 1, let's say, and game objects, and I'm going to pass in ID 2. And that, my friends, will be how I can use the objects that are inside of game objects, right? So instead of me specifying exactly which ones, I can specify whichever ones I want. Let's enter 3, but I only want the distance between the first one and the third one to test this out. So here, I'm going to do that. I'm going to go here. It's going to say, how many objects do I need? I need 3 objects. Cool. ID for the first one is 1. And it's 3, 4. Okay. ID for the second one is 2. And it's 10, 20. And ID for the third one is 3. And I need it to be at 100, 200. Cool. Okay. We've got all that data in. Wonderful, wonderful. Now, what is the first object ID that I'm going to compare to? I'm going to compare ID number 1. What is the second object ID? ID number 3. And then I get a wonderful error. All right. Now, this happens sometimes, right? Totally happens. So let's find out what's going on and what could be. It says, well, I made a mistake. I wanted ID number 3, right? I took ID number 3 and ID number 1, but I really meant the ID of those things, not the index. All right, so I'm almost there. Let's do it one more time. I'm going to abort. I passed in ID, and I'm not doing any checking here. Remember that. So what is the ID, the first ID? Well, the ID that I've put in, I can't search by ID. Let's use this instead of, to not complicate things. What is the first object index, we'll say, not ID. Because some people might say it's the ID, and I'm not making an associative array here. So you can't search by ID. We'll call this index 1. Index 1. And you can see easily that we can make as many comparisons as we want if I did this in a different way, right? We can also make loops happen here. Index 2. Just to be you know, kind of for completeness. 1 and index 2. There we go. That's what I meant. Okay, so it's index, just so that we know, the user knows. I didn't even know. The user knows what I want now. Okay, let's try one more time, and this last time. So I need 3 objects. The first ID is 1. It's 3, 4. 2 is, let's say, 10. Oops. It'd be nice if I can enter it all at once. 10, 20. And the third one is 3, and that is 100, 200. Okay, which the first object index, 0. And the second object index, 2. Ba-bum. And we have the comparison, 5. The magnitude of the first object is 5, 3, 4. The magnitude of the second object, game object, is 223.607. The distance between the two is 218 units, whatever those are. The angle in degrees is 10. And this is the first game object and the third game object. You can see that those are there. So pretty good, right? That's how you can use those things. And again, we have no checks. There's lots of more stuff that we can do here. All we're doing is literally our main is a test rig. That's all it is, to test our structures. And we can also do things like describe things that are missing in here. Like, for example, it would be really nice for me to be able to enter everything at once in my game object, my ID, my X and my Y axis, all in one line. And I haven't done that here. That's not how I enter stuff, right? Because it's a much quicker way of entering things. I would like that to happen. I would also like it so that when I compare two things, it's going to say which two items that I want to compare, and I want to compare by ID. I don't want to compare necessarily by index, because that's not natural for us to know which index the object is. What if I just want to search for that ID? I need to make a find object by ID method. And now once we go into that, these methods that I've created here can be methods that I can use for some kind of game object construction class, or some kind of factory, a game object factory, where I build game objects. I can compare two game objects together, something like that. And I don't have that right now, but I could make a class to do all this thing for me, as opposed to me doing it here in main. And this is what we're going to do as we go forward in the next section. All right, so that's it for me. That's all you need to do. Let's put this up on GitHub. So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. I want to say I'm going to added implementation in main, right? Commit all. I'm going to go to Home, Sync, and Push. And that's going to push everything up to GitHub for you. So that's it for today. Any questions before we go? As we made a very simple example, lots more things we can do here with our game object. But just as a recap, what we did was we used composition. We have a complex type, a vector2 object we created, which is a full class with all of the details that we would have in a more complex Cartesian point class. That's what we did. What we also can do is we made a test method in main that allows me to enter objects. We've created a vector of game objects that are pointers to the game object. One thing we haven't done here is clean up, right? What we should do, if you think about this, is delete all my game objects when we're leaving, because then we're going to have a memory leak in this program, right? What we're doing is we're allocating memory on the heap with the new keyword. Anytime we use the new keyword, which is what we're doing here, when we add a new game object, by the way, we could have done this all in one, right, just by putting it in here. But whenever we use new as to add a pointer, we add memory to the heap. And what's happening is when we allocate memory to the heap, we're not releasing it. Every time we run our program, we have a bit of a memory leak happening every single time. So we want to be able to take care of it by releasing the memory at the end, free that memory, right? And we can do that by using the delete keyword that deletes the pointer. But we want to delete each of the pointers to that exist as an example inside of our vector. So there's a couple of ways to do that. We can loop through the vector and delete each one of them one by one. And when we do that, when we delete the vector, that'll get rid of the object. So first we want to pop it, and then we want to delete the pointer to the vector, and that will be something, and we can set it to null. So there's like many ways. From a memory management perspective, we're not there yet. This is just the first layer of using dynamically allocated objects. Okay, any questions for me before we go? I'm going to stop recording now, and I'll take your questions.